You are listening to Ubuntu Server Savvy, a practical guide for administrators. Like and subscribe to keep up to date on our latest audiobooks. Ubuntu Server Savvy, a practical guide for administrators. Chapter 1, Welcome to Ubuntu Server, your foundation. Welcome, future server administrator. You're about to embark on a fascinating journey into the world of server management with Ubuntu Server. Whether you're a seasoned IT professional looking to broaden your Linux skills, a small business owner aiming to host your own services, or a curious hobbyist eager to get hands-on with powerful technology, this book is your practical guide. Ubuntu Server is a powerful, versatile, and free operating system widely used for everything from small home media servers to large-scale enterprise data centers. Its popularity stems from its robust nature, strong security features, and a vast, supportive community. Unlike desktop operating systems that prioritize a graphical interface for everyday tasks, Ubuntu Server is lean, efficient, and designed to run headless, meaning without a monitor, keyboard, or mouse, primarily accessed through the command line. This might sound intimidating at first, but it offers unparalleled control and efficiency once you get the hang of it. Think of a server as the engine room of the modern digital world. It's a specialized computer designed to provide services to other computers, which we call clients. These services can be anything from hosting websites, storing and delivering files, managing databases, sending and receiving emails, or even running complex applications for a business. Every time you browse a website, send an email, or stream a movie, a server somewhere is making it happen. Why Ubuntu Server? Among the many Linux distributions available for server use, Ubuntu Server stands out for several compelling reasons. Ease of use for beginners. While it's command-line-centric, Ubuntu's robust documentation and a consistent approach to configuration make it relatively easy to learn. The apt package management system simplifies software installation and updates immensely. Stability and reliability. Ubuntu is built on top of Debian, a highly stable Linux distribution, inheriting its reliability. This means your server will run consistently, reducing downtime and maintenance headaches. Strong security track record. Ubuntu receives regular security updates, often within hours of vulnerabilities being discovered. Its default configuration emphasizes security, and it provides excellent tools like the uncomplicated firewall or UFW to protect your server. Vast community and resources. If you ever get stuck, chances are someone else has faced the same issue. Ubuntu boasts one of the largest and most active Linux communities, offering a wealth of online forums, wikis, and tutorials. Long-term support, LTS, releases. Canonical, the company behind Ubuntu, offers LTS versions that are supported for 5 years. This is ideal for servers, as it means you can deploy a system and rely on continuous updates and support for an extended period without needing frequent upgrades. Cloud integration. Ubuntu Server is the most popular operating system in public clouds like Amazon Web Services, Microsoft Azure, and Google Cloud. Learning Ubuntu Server skills translates directly to managing cloud-based infrastructure. Cost-effective. It's completely free to download, use, and distribute. This allows you to build powerful server infrastructure without licensing costs, making it accessible for individuals and small businesses alike. Throughout this book, we'll strip away the jargon and focus on practical, actionable steps. You'll learn how to transform a plain computer into a secure, robust server capable of handling essential tasks. We'll start with the very basics, like installing the operating system, and gradually build up to configuring web servers, databases, and file-sharing services. What you'll need to get started. Before diving in, here's a quick checklist of what you'll want to have ready. A dedicated computer. This can be an old desktop PC, a spare laptop, or even a virtual machine. It doesn't need to be state-of-the-art. Most basic server tasks are not extremely resource-intensive. If you're using a virtual machine, software like VirtualBox or VMware Workstation Player are excellent free options. Internet access. You'll need this during installation and for downloading software updates and packages. A USB drive, at least 4 GB. This will be used to create bootable installation media for your physical server. If you're using a virtual machine, you can often directly use the downloaded disk image. Basic computer literacy. Familiarity with concepts like files, folders, and opening applications will be helpful. No prior Linux experience is required. Don't worry if all of this sounds like a lot right now. We'll break down each step into simple, manageable pieces. By the end of this book, you'll not only have a functioning Ubuntu server, but also a strong understanding of fundamental Linux administration principles. Let's begin building your server savvy. Chapter 2, Setting Up Shop, Installation and Initial Configuration. Now that you're ready to dive in, let's get Ubuntu Server installed on your chosen hardware or virtual machine. The installation process for Ubuntu Server is designed to be straightforward, guiding you through the necessary steps with clear prompts. Because Ubuntu Server typically operates without a graphical desktop environment, the setup process is text-based but highly intuitive. Getting the installation media. The first step is to acquire the Ubuntu Server installation image. This is a special file, usually with an ISO extension, that contains all the necessary components to install the operating system. Download the ISO image. Visit the official Ubuntu website, specifically the server download section. Look for the latest long-term support, or LTS, release. As discussed in Chapter 1, LTS versions are recommended for servers due to their extended support cycle. Download the appropriate ISO file for your system's architecture, which for most modern computers will be AMD 64. Create bootable media for a physical server. Once the ISO is downloaded, you'll need to burn it to a USB drive, making the drive bootable. There are several excellent free tools for this, such as Balna Etcher or Rufus. Insert your USB drive into your computer, open your chosen tool, select the downloaded ISO file and your USB drive, and then start the process. This will erase everything on the USB drive, so ensure you've backed up any important data. For a virtual machine, if you're using a virtualization platform like VirtualBox or VMware, you typically don't need a USB drive. Instead, you'll configure your virtual machine to boot from the downloaded ISO file directly. In your virtual machine settings, look for the storage or CD/DVD settings and select the ISO file as the virtual optical drive. The installation process. With your bootable media ready, it's time to install. Boot from the installation media, physical server, insert the USB drive and restart your computer. You may need to press a special key, often F2, F10, F12, or delete, during startup to enter your computer's BIOS or UEFI settings, or to bring up a boot menu. From there, select your USB drive as the boot device. Virtual machine. Start your virtual machine. It should automatically boot from the ISO file you configured. Language and keyboard layout. The installer will greet you with a choice of language. Use the arrow keys to navigate and the Enter key to select. Next, you'll be asked to select your keyboard layout. The installer can often detect this for you, or you can choose it manually. Network configuration. This is a crucial step. The installer will attempt to configure your network automatically using DHCP, Dynamic Host Configuration Protocol, which assigns an IP address automatically. For a server, you'll often want a static IP address, meaning it never changes. Don't worry if you don't set a static IP here, we can configure it later. For now, if DHCP works, accept it to continue. If you face issues, ensure your network cable is connected or your virtual machine's network adapter is correctly configured. Proxy server, optional. If your network requires a proxy server to access the internet, you would enter its details here. For most home or small office setups, this can be left blank. Mirror address. Ubuntu downloads software packages from mirrors, which are copies of the main software repositories. The installer will suggest a mirror close to your geographical location. Accept the default unless you have a specific reason to change it. Hard drive setup. This is a critical step where you tell Ubuntu where to install. The simplest option is usually use an entire disk. This will erase all data on the selected hard drive and install Ubuntu Server there. Be extremely careful here. Ensure you select the correct disk if you have multiple. For more advanced users, or if you want to partition your disk manually, there are options for custom storage layout. Since this book is for beginners, we recommend starting with the Use an entire disk option. You may also be presented with an option to set up LVM, Logical Volume Management. LVM provides flexibility for managing disk space later on, but for a basic setup, it's not strictly necessary. You can opt to install without it for simplicity. Profile Setup, User Account, you'll be prompted to create your primary user account. Your name, enter your full name. Your server's name, this is the host name of your server. Choose something descriptive and easy to remember, like My Web Server or Home Server. Username, this will be the name you use to log in. Keep it lowercase with no spaces. Password, choose a strong, complex password. Combine uppercase and lowercase letters, numbers, and symbols. You'll need to enter it twice to confirm. SSH Setup, Secure Shell, you'll be asked if you want to install OpenSSH Server. Definitely select this option. SSH is the primary way you'll connect to and manage your server remotely from another computer, enabling you to use the command line without needing a physical keyboard and monitor attached to the server. You can also import an SSH key here for passwordless login, but we'll cover that more in Chapter 4. For now, simply ensure OpenSSH Server is selected for installation. Featured snaps, optional. The installer might suggest some popular server applications to install immediately as snaps, a packaging system. For your first installation, you can deselect these and install what you need later to keep things cleaner. 10. Begin installation, review your choices. If everything looks correct, select Done to begin the installation. The installer will now copy files and configure your system. This process can take some time, depending on your hardware. 11. Installation complete. Once the installation finishes, you'll be prompted to reboot. Remove your USB installation media, or unmount the ISO from your virtual machine before restarting. Your first login. After the server reboots, you'll be greeted by a command line interface, a black screen with text, and a login prompt. This is your server. Type the username you created during installation and press enter. Then, type your password. Characters will not appear as you type for security, and press enter. Congratulations! You are now logged into your Ubuntu server. You'll see a command prompt, something like username at servername, $, or username at servername $. The tilde symbol represents your home directory, and the dollar indicates you are a regular user. Initial post-installation tasks. Before we dive deep into commands, let's perform 2 essential tasks. Update your server. It's crucial to update your server immediately after installation to ensure you have the latest software and security patches. First, refresh your package list by running the command sudo apt update. The sudo part is vital here. It allows you to execute commands with administrative privileges. You'll be prompted for your user password. Next, upgrade all installed packages to their latest versions by running sudo apt upgrade. This command will list packages that can be upgraded and ask for confirmation. Type Y and press enter to proceed. Finally, to clean up any old, unnecessary packages that were installed as dependencies but are no longer needed, run sudo apt auto remove. This keeps your system tidy. Set a static IP address, optional but recommended for servers. While DHCP is convenient, a server typically needs a consistent IP address so other devices can reliably find it. We configure network settings using NetPlan, a utility for configuring network interfaces on Ubuntu. To find your network interface name, you can run the command IP. Look for an interface usually named NS3 or NP08 and note it down. Now, we need to edit a NetPlan configuration file. This file is often located at /etc/netplan/00installerconfig.yaml or similar. To edit it, we'll use a text editor called nano. Run the command sudo nano /etc/netplan/00installerconfig.yaml. Inside the file, you'll see a section that begins with network, followed by version, and renderer. Under the Ethernets section, you'll find your network interface name, possibly followed by DHCP4, true. We need to change DHCP4, true to DHCP4. No and add static IP configuration. When you replace the configuration, it should look something like this example. Remember to replace the placeholder details with your actual network's information. The file should describe your network settings, indicating version 2 with a renderer called networked. Under the Ethernet section, specify your interface, for example, ENS and the number 3. Ensure that DHCP4 is set to no. Then, define your desired addresses, for example, 192.168.1.100/24, which is your static IP address and subnet mask. Next, define routes specifying to default and your VIA gateway address, which is typically your router's IP, like 192.168.1.1. Finally, for name servers, list your preferred DNS server addresses, such as your router's IP and public DNS servers like Google's 8.8.8.8. Crucial details to replace: your network interface name from IP your desired static IP address, e.g., 192.168.1.100. Make sure it's outside your router's DHCP range to avoid conflicts, but within your network subnet. The subnet mask, e.g., 24 for most home networks, representing 255.255.255.0. Your network's gateway, which is usually your router's IP address, e.g., 192.168.1.1. The DNS servers your server will use to resolve domain names. You can use your router's IP, your ISP's DNS, or public ones like Google's 8.8.8.8, 8.8.8.8, and 8.8.4.4, 8.8.4.4. After making these changes, press Ctrl+X to exit Nano, then Y to save the changes, and Enter to confirm the file name. Apply the new netplan configuration by running sudo netplan apply. If there are any errors in your configuration, this command will usually tell you. You can verify your new IP address by running IP again. Your server should now have the static IP address you assigned. Take a moment to absorb what you've just accomplished. You installed a complete operating system, configured its network, and performed essential updates. In the next chapter, we'll dive deeper into the command line, equipping you with the fundamental skills to navigate and control your Ubuntu server effectively. Chapter 3, The Command Line Chronicles, Navigating and Mastering Your Server. You've successfully installed Ubuntu Server and had your first taste of the command line. Now, let's unlock its true power. The command line, often referred to as the terminal or shell, is your primary interface for interacting with and managing your server. While it may seem daunting at first compared to a graphical desktop, it offers unparalleled efficiency, precision, and the ability to automate tasks. Think of the command line as talking directly to your server in its native language. Instead of clicking icons, you type instructions. This chapter will equip you with the essential commands and concepts to navigate, create, modify, and manage files and directories. Understanding the prompt. When you log in, you'll see a prompt similar to username at servername $. Username, this is the user you are currently logged in as. The symbol separating the username and server name. Server name, the host name you set during installation. This is a special symbol representing your current directory. In this case, it means you are in your home directory. Every user on a Linux system has a home directory where their personal files are stored. This indicates that you are logged in as a regular user. If you were logged in as the powerful administrator user, root, or if you use sudo to gain temporary root privileges, the prompt might end with a hash symbol instead. Getting help, man pages. Before we dive into commands, know this. For almost any command on Linux, there's a detailed manual page or man page. To access it, simply type man followed by the command name. For example, to learn about the ls command, you would type man ls, read as man space ls. To exit a man page, press the Q key. Basic navigation commands. Mastering navigation is fundamental. pwd, print working directory. This command tells you exactly where you are in the directory structure. To use, simply type pwd, read as pwd. Output will be something like /home/ your username. ls lists directory contents. This command lists the files and directories in your current location. To list contents of the current directory, ls read as. ls, to list contents, including hidden files and detailed information permissions, ownership, size, date. ls law, read as, ls space hyphen lha. The hyphen L option means long listing format. The hyphen H option means human-readable sizes, e.g., 1K instead of 1024. The hyphen A option means all files, including hidden ones, those starting with a dot like .bashrc. cd change directory, this is how you move around. To go back to your home directory from anywhere. cd read as. cd or cd read as, cd space tilde. To go up one directory level, cd read as, cd space dot dot. To go to a specific directory using its absolute path, cd var/log, read as, cd space /var/log. To go to a subdirectory using a relative path, cd my directory, read as, cd space my underscore directory. To go to the previous directory you were in, cd read as, cd space hyphen. Example scenario, you log in, username at server $. You want to see logs, type cd var/log. Now your prompt changes to reflect your new location, for example, username at server /var/log $. You check log files, type ls. You want to go back to your home directory, type cd. Now you're back at your home directory prompt. Username server. Creating, copying, moving, and deleting. mkdir make directory creates new directories. To create a single directory, mkdir new folder, read as. mkdir space, new underscore folder. To create a directory and its parent directories if they don't exist. mkdir p projects /myapp /data, read as. mkdir space, hyphen p space projects /my underscore app /data. Touch create empty file, creates empty files or updates the timestamp of existing ones. To create an empty file, touch mynotes.txt, read as, touch space my underscore notes.txt. cp copy copies files and directories. To copy a file, cp sourcefile.txt destination folder / read as. cp space source underscore file .text space destination underscore folder /. To copy a file and rename it in the same step, cp old name.txt new name.txt. To copy a directory and its contents recursively, cp r source directory / destination directory / read as. cp space hyphen r space source underscore directory / space destination underscore directory / mv move rename. Moves files and directories or renames them. To move a file, mv file.txt path / to / new location / read as mv space file.text space /path / to / new underscore location /. To rename a file, mv old name.txt new name.txt. To rename a directory, mv old folder / new folder /. rm remove deletes files and directories. Use with extreme caution. There is no recycle bin on the command line. To delete a file, rm unwanted file.txt, read as rm space unwanted underscore file.txt. To delete an empty directory, rmdir empty folder, read as rmdir space empty underscore folder. To delete a non-empty directory and its contents recursively, rmr folder with contents / read as rm space hyphen r space folder underscore with underscore contents /. To delete files without confirmation, use with even more caution, rm f real unwanted file.txt, read as rm space hyphen f space really underscore unwanted underscore file.txt. Never use rmrf, read as rm space hyphen rf space / or rmrf, read as rm space hyphen rf space asterisk, unless you explicitly know what you are doing, as they can wipe your entire system or current directory contents without warning. Viewing file contents. Cat concatenate and displays the entire content of a file on the screen, best for small files. To view a file, cat mydocument.txt, read as cat space my underscore document.txt. Less pager displays file content page by page, allowing you to scroll, search, and navigate. Good for larger files. To view a file, less largelog file log, read as less space large underscore log underscore file.log. While in less, press the spacebar to scroll down, the B key to scroll up, the / key to search, the N key for the next match, and the Q key to quit. Head and tail show the beginning or end of a file, useful for logs, to see the first 10 lines. Head syslog read as head space syslog. To see the last 10 lines. Tail syslog read as tail space syslog. To continuously monitor new lines being added to a file, like a live log. Tail fvar/log/syslog read as tail space -f space /var/log/syslog. Press Ctrl+C to exit. The power of sudo. Sudo stands for superuser do. It allows a regular user to execute commands with the security privileges of another user, most commonly the root user, the administrator. When you created your user during installation, it was automatically added to the sudo group, granting it this ability. You'll use sudo for administrative tasks like installing software, modifying system configuration files, or restarting services. When you use sudo for the first time in a session, you'll be prompted for your own user password. This is a security measure to ensure you are intentionally performing administrative actions. Example, sudo apt update, read as. Sudo apt update. This command updates the package list with root privileges. Command line efficiency tips. Tab completion. This is your best friend. Start typing a command, file name, or directory name, then press the tab key. The shell will try to auto-complete it for you. If there are multiple possibilities, press tab twice to see all options. Arrow keys. Use the up and down arrow keys to cycle through your command history. This saves a lot of typing. Ctrl+C terminates the currently running command or process. To press this, hold down the Control key and press the C key. Ctrl+L clears the terminal screen. To press this, hold down the Control key and press the L key. History. The History command shows you a list of all commands you've recently executed. Text editing with nan. While there are more powerful text editors like Vim read as, Nano read as. Nano is excellent for beginners due to its simplicity and on-screen help. We already used it in Chapter 2. To open a file for editing, nano myconfig.conf, read as. Nano space my_config.conf. If the file doesn't exist, Nano will create it. At the bottom of the screen, Nano shows common shortcuts. For example, Caretex, often communicated as Ctrl+X. This means to hold down the Control key and press X to exit. Careto, often communicated as Ctrl+O. This means to hold down the Control key and press O to write out save. Remember to use sudo nano when editing system configuration files that require root permissions, for example. Sudo nano etc. network interfaces, read as. Sudo nano space / etc. / network / interfaces. A word on paths, absolute versus relative. Absolute path starts from the root directory / and specifies the full location. Example, /home / your username / documents / report.txt. Relative path specifies a location based on your current * directory. ./myfile.txt refers to myfile.txt in the current directory. The dot means current directory. /another folder / image.jpg refers to image.jpg in another folder, which is one level up from your current directory. The double dot means parent directory. Understanding and using the command line effectively will be key to your success as an Ubuntu server administrator. Practice these commands regularly, experiment in your home directory, and don't be afraid to use man pages. With each command you master, you're gaining more direct control over your server. In the next chapter, we'll put some of these skills to use as we secure your Ubuntu server. Chapter 4. Fortifying your fortress. Essential security measures. You've got your Ubuntu server up and running, and you're comfortable with the command line. Now it's time to talk about one of the most critical aspects of server management, security. Your server, once connected to the internet, becomes a potential target for malicious actors. It's not a matter of if someone will try to access it, but when. Thankfully, Ubuntu provides excellent tools and best practices to help you build a robust defense. Think of your server as a valuable fortress. You wouldn't leave its gates wide open for anyone to walk in. Similarly, we need to secure its access points, manage its inhabitants, and keep its defenses up to date. The principle of least privilege, user management. The first line of defense is proper user management. The principle of least privilege dictates that users should only have the minimum permissions necessary to perform their tasks. You created a personal user account during installation, which is a great start. You avoid logging in directly as the root user, which has absolute power over the system and should be used sparingly, if at all, for direct logins. Your personal user, instead, has been granted the ability to temporarily assume root privileges using the sudo command, as we discussed in Chapter 3. Here's how you can manage other users on your system. Adding a new user. If multiple people need access to your server, create separate accounts for each of them. To add a new user, you'd use the command sudo adducer new surname, read as sudo add user space new username. The system will prompt you to set a password for the new user, and then ask for some optional information like full name, room number, and so on. You can just press enter to skip these optional details. Granting sudo privileges. If this new user needs to perform administrative tasks, you'll need to add them to the sudo group. The command is sudo usermod ag sudo new surname, read as sudo usermod space hyphen ag space sudo space new username. The hyphen a option appends the user to the group, and G specifies the group. Deleting a user. If a user no longer needs access, remove their account. To delete a user but keep their home directory, sudo deluser username, read as sudo del user space username. To delete a user and their home directory, sudo deluser remove home username, read as sudo del user space double hyphen remove home space username. Strong passwords. This may seem obvious, but it's worth reiterating. Every user account on your server must have a strong, unique password. A strong password combines uppercase and lowercase letters, numbers, and symbols, and is at least 12 to 16 characters long. Avoid dictionary words, personal information, or easily guessed sequences. Password managers can greatly assist you in generating and storing these complex passwords securely. SSH hardening. Securing your access port. SSH, or Secure Shell, is your primary tool for remotely managing your server, as installed in Chapter 2. Because it's the gateway to your server, it's a prime target for attackers. We're going to implement two crucial security measures: disabling password authentication and enabling SSH key-based authentication. Why disable password authentication? Attackers often use automated brute force programs that try thousands of common passwords against your server's login. If your password is weak or even moderately strong, it could eventually be guessed. By disabling passwords, you make these automated attacks useless. SSH key-based authentication relies on a pair of cryptographic keys: a private key that stays securely on your local computer, a public key that you upload to your server. When you try to connect, your local computer sends a request to the server, and the server challenges it. Your computer then proves its identity by performing a cryptographic operation using your private key. The private key never leaves your computer, making this method far more secure than passwords. Let's set it up. Generate SSH keys on your local computer. Open a terminal on your local machine, your desktop or laptop, not the server. Type SSH keygen, read as SSH-keygen. You'll be asked where to save the key. Default is usually fine, just press enter, and to enter a passphrase. Always use a strong passphrase for your private key. This is an extra layer of security, requiring you to enter this passphrase to unlock your private key. If your local computer is ever compromised, this passphrase protects your private key. This command will create two files, typically IDASA, your private key, and IDASAPub, your public key, in a hidden folder called ssh.ssh in your home directory. Copy your public key to the server. The easiest way is to use the ssh copyid command from your local computer. Type ssh copyid username at your server IP. Read as ssh-copy-id space username at your _server_IP. Replace username with your username on the server, and your server IP with your server's IP address, the static IP you set in Chapter 2. You'll be prompted for your server password. Enter it, and the public key will be copied to the authorized keys file in your server's SSH folder. Test key-based login. Before making any changes to the SSH server configuration, test your key-based login. From your local computer, try to connect to your server without specifying a password. SSH username at your server rep. If you set a passphrase for your private key, you'll be prompted for that. Otherwise, you should log in directly. If it works, great. If not, troubleshoot before proceeding. Disable password authentication on the server. Now that you know key-based login works, let's turn off passwords. On your server, logged in via SSH with your key, open the SSH daemon configuration file for editing. Sudo nano etc/ssh/ssh deconfig. Read as sudo nano /etc/ssh/sshd_config. Find the line that says password authentication yes. Change yes to no. While you're in this file, it's also a good practice to change the permatroot login setting to no. It often is by default on Ubuntu server, and to ensure you spam is set to yes. Press Ctrl+X, then Y, then enter to save and exit nano. Restart the SSH service for changes to take effect. Sudo systemctl restart SSH. Read as sudo systemcontrol restart SSH. Now, your server will only accept SSH connections from clients presenting a valid SSH key associated with a user account. This drastically reduces your server's exposure to brute force attacks. Firewall configuration with UFW, uncomplicated firewall. A firewall acts like a security guard for your server, deciding which network traffic is allowed in and out. Ubuntu comes with UFW, or uncomplicated firewall, as its default firewall management tool. It's designed to be user-friendly while providing robust protection. By default, UFW is often inactive after installation. The general strategy for a firewall is to deny all incoming, allow only necessary outgoing. Check UFW status to see if UFW is active. Sudo UFW status. Read as sudo UFW status. If it says status inactive, it's not currently protecting your server. Allow SSH, crucial first step. Before you enable UFW, you must allow SSH. Otherwise, you will lock yourself out of your server. To allow SSH connections, sudo UFW allow SSH. This automatically configured port 22, the default SSH port. Alternatively, you can specify the port number. Sudo UFW allow 22. Enable UFW. Now that SSH is allowed, you can activate the firewall. Type sudo UFW enable. You'll be warned that this command might disrupt existing SSH connections. Type Y and press enter to confirm. Check the status again. Sudo UFW status. It should now show status, active, and list your allowed rules. Allow other services as needed. As you configure your server to host web services or databases, you'll need to open specific ports. For a web server, HTTP. Sudo UFW allow HTTP or sudo UFW allow 80, port 80. For a secure web server, HTTPS. Sudo UFW allow HTTPS or sudo UFW allow 443, port 443. For a MySQL database, sudo UFW allow 3306, port 3306. For a PostgreSQL database, sudo UFW allow 5432, port 5432. You can also specify particular IP addresses to allow access from. For example, to allow HTTP from only one specific IP address, sudo UFW allow from your specificip to any port 80. Deny services. If you need to explicitly block a service, you can use deny. However, since UFW's default incoming policy is usually deny, you generally only need to focus on what you allow asterisk. Example, sudo UFW deny from 192.168.1.5 to block all traffic from a specific internal IP. Delete rules to remove an existing rule. First, list numbered rules. Sudo UFW status numbered. Then delete by number. Sudo UFW delete rule number, e.g., sudo UFW delete 3 to delete rule number 3. Reset firewall. To revert UFW to its default state, all rules removed, inactive. Sudo UFW reset, use with extreme caution, as this will disable all current active firewall rules and could lock you out if you're connected remotely. Regular security updates. We briefly touched on this during the initial setup, but it bears repeating. Keeping your server's software up to date is paramount for security. Software vulnerabilities are constantly discovered. Developers release patches to fix them, and you need to apply those patches promptly. You should run these commands regularly, ideally once a week or immediately after a security announcement. Sudo apt update, read as. Sudo apt update refreshes the list of available updates. Sudo apt upgrade, read as. Sudo apt upgrade installs all available updates. Sudo apt auto remove, read as. Sudo apt auto remove cleans up old, no longer needed packages. For critical security updates, you can also configure unattended upgrades to automatically install them in the background. While this reduces manual effort, it's wise to occasionally check in on your server to ensure everything is updating correctly. You can research Ubuntu unattended upgrades for detailed setup instructions if you wish to automate this. Building a secure server is an ongoing process, not a one-time setup. By implementing strong user practices, securing SSH access, rigorously controlling network traffic with a firewall, and consistently applying updates, you lay a strong foundation for your Ubuntu server. In the next chapter, we'll dive into the intricacies of managing software on your system using Ubuntu's powerful package management tools. Chapter 5. Managing your software. The Ubuntu package system. In the previous chapters, you've brought your Ubuntu server to life, learned to navigate its command line, and locked down its initial security. Now, let's talk about the software that makes your server do amazing things. Whether you want to install a web server, a database, or even a simple utility, you'll rely heavily on Ubuntu's robust package management system. Think of a package manager like a highly organized, automated software store. Instead of manually downloading, compiling, and installing every program and all its dependencies, which used to be a painful process in the early days of Linux, the package manager handles it all for you. It knows where to find trusted software, checks for conflicts, resolves dependencies, and installs everything correctly. This ensures consistency, simplifies updates, and enhances system stability. Ubuntu primarily uses the apt, Advanced Package Tool system, a powerful and user-friendly interface to manage software packages. You've already had a brief introduction to apt when you updated your server in Chapter 2 and Chapter 4. Now let's explore its full capabilities. The foundational commands, apt update and apt upgrade. These two commands are the cornerstones of keeping your server healthy and secure. You should run them regularly. Sudo apt update, read as. Sudo apt update, refreshing the package list. This command does not install new software or upgrade existing ones. Instead, it downloads the latest information about available packages from the Ubuntu software repositories. These repositories are collections of software maintained by Ubuntu and its community. It's like getting a fresh catalog of all the books available in the library. Without updating the catalog, you won't know about new arrivals or improved editions. Example, sudo apt update. You'll see it fetching information from various URLs, indicating that it's retrieving the latest package metadata. Sudo apt upgrade, read as. Sudo apt upgrade. Upgrading installed packages. After you've updated your package list, apt upgrade actually installs the newer versions of software packages that are already present on your system. It compares the versions you have installed with the versions listed in the updated catalog and installs any newer ones. This is crucial for security patches and bug fixes. Example, sudo apt upgrade. A list of packages to be upgraded will appear, and you'll be asked to confirm type Y and press enter. Sometimes, after a significant kernel update or other core system changes, apt might suggest a sudo apt dist upgrade, read as. Sudo apt dist -upgrade. This command handles dependency changes intelligently and can remove old packages if they conflict with new ones. Use it when prompted or if an apt upgrade indicates there are held packages. Installing new software, apt install. This is how you get new applications onto your server. Basic installation. To install a package, you use sudo apt install package name, read as. Sudo apt install package name. Apt will automatically calculate and install any other packages dependencies that package name needs to function. Example, to install the Apache 2 web server. Sudo apt install Apache 2, read as. Sudo apt install Apache 2. Apt will show you what will be installed and how much disk space it will consume, then ask for your confirmation. Installing multiple packages. You can install several packages at once by listing them with spaces in between. Example, sudo apt install nano git curl, read as sudo apt install nano git curl. Removing software. Apt remove and apt purge. Sometimes you need to get rid of software. Sudo apt remove package name, read as sudo apt remove package name, removing the software package. This command removes the specified software package, but it typically leaves behind configuration files. This can be useful if you plan to reinstall the software later and want to retain your settings. Example, sudo apt remove apache 2. Sudo apt purge package name, read as sudo apt purge package name. Removing software and configuration files. This command removes the software package and its associated configuration files. Use this when you want a complete removal, as if the package was never installed. Example, sudo apt purge apache 2. Sudo apt autoremove, read as sudo apt autoremove, cleaning up dependencies. When you install a package, apt might pull in other dependent packages that package name needs. When you remove package name, those dependencies might no longer be needed by any other software. Apt autoremove identifies and removes these automatically installed dependent packages that are no longer used by anything else on your system. It helps keep your system lean and tidy. You should run this periodically after removing applications. Example, sudo apt autoremove. Searching for software, apt search. If you know what a piece of software does, but not its exact package name, apt search is invaluable. To search for packages, apt search keyword, read as apt search keyword. It will search package names and descriptions for the keyword you provide. Example, apt search web server, read as apt search web server. This might show results for Apache, Nginx, Lite, and so on. The output will include the package name, version, and a brief description. Other useful apt commands. Apt show package name displays detailed information about a specific package, including its description, dependencies, size, and source. Example, apt show apache 2. Apt list installed shows all currently installed packages. Example, apt list installed. Apt list upgradable lists all packages that have updates available. Example, apt list upgradable. Software repositories and PPAs. Where does apt get all this software information and the packages themselves? From software repositories. These are servers that host vast collections of precompiled software. Ubuntu comes configured with several official repositories, such as main, open source software officially supported by Ubuntu; universe, community-maintained open source software; restricted, proprietary drivers that are essential for hardware; multiverse, software that is restricted by copyright or legal issues. The list of repositories your system uses is defined in files located in the directory /etc/apt/sources.list.d. You typically don't need to manually edit sources list, as tools handle it for you. PPAs, Personal Package Archives. Sometimes, software developers or communities want to distribute their software directly or provide newer versions than available in the official Ubuntu repositories. They can do this via PPAs. Adding a PPA involves adding another repository to your system's apt sources. While convenient, be cautious when adding PPAs. Only add PPAs from sources you trust, as they can potentially introduce security risks or system instability if not properly maintained. To add a PPA, sudo adapt repository PPA, PPA name /PPA, read as sudo add-apt-repository PPA :PPA _name /PPA. After adding a PPA, you must run sudo apt update to refresh your package list and pull in information from the new repository. Mastering apt is fundamental to managing your Ubuntu server. It allows you to confidently install, update, and remove software, keeping your system secure and performing its desired functions. In the next chapter, we'll delve into the very structure of your server, exploring the Linux file system, file permissions, and how storage is managed. Chapter 6. Files, Permissions, and Storage. Understanding the Linux file system. So far, you've installed Ubuntu Server, learned how to navigate and manage it using the command line, secured its access points, and mastered software installation. Now, it's time to peel back another layer and understand the very foundation upon which your server operates: the Linux file system. Unlike operating systems that might have multiple drive letters, like C drive, D drive, Linux organizes everything into a single, unified directory tree, starting from the root directory, represented by a single /. Every file, every directory, every piece of hardware is accessible somewhere within this tree. Understanding this structure is crucial for knowing where to find configuration files, logs, user data, and system binaries. The standard Linux directory structure. Let's explore some of the most important directories you'll encounter on an Ubuntu server. /root. This is the top-level directory of the entire file system hierarchy. Everything else branches off from here. /bin binaries contains essential command line utilities and user commands like ls, cp, mv used by all users. sbin system binaries. Similar to bin, but contains system administration commands like fdisk, reboot, typically used by the root user or with sudo. Boot contains files needed to boot the operating system, including the Linux kernel. Do not modify anything here unless you are absolutely certain what you are doing. Dev devices contains special files that represent hardware devices, like hard drives, USB devices, network cards. You interact with these indirectly, usually. You don't store regular files here. Etc., etc. This is a critical directory for server administrators. It contains system-wide configuration files, for example, /etc/ssh/sshDconfig, which we edited in Chapter 4, or etc/netplan for networking, etc. apt for package management. These are plain text files you can edit with nano. Home. This is where the personal home directories for regular users are created. For example, if you created a user named adminuser, their home directory would be home/adminuser. Lib libraries contains shared libraries, which are pieces of code used by many different programs. Media, a temporary mount point for removable media like USB drives or optical discs. /mnt mount, a common temporary mount point for mounting file systems, often used for temporarily connecting an external hard drive. Optional, used for installing optional or third-party software that is not part of the standard distribution. Processes, a special virtual file system that provides information about running processes and kernel information. It's not a real disk location, but a reflection of the system's current state. Root, this is the home directory for the root user, the superuser account. It is separate from home to ensure the root user can still log in even if the home partition is unavailable. Run, a temporary file system that provides information about the system since it was last booted. /srv services contains data for services provided by the system, like web server data or shared file data. For example, your web server's files might live in /srv/www. /sys system, another virtual file system, similar to proc, providing an interface to kernel data structures. TMP temporary, a directory for temporary files. Contents are often cleared on reboot. Do not store anything important here. /usr user system resources. Originally, user programs, it now contains all userland applications and utilities. Many programs you install will likely place their executable files in usr/bin or /usr/sbin. Var variable contains variable data, meaning files that change frequently. This includes log files /var/log, mail queues /var/mail, web server content /var/www/html if not using /srv, and database files /var/lib/mysql. When troubleshooting, /var/log is a key place to look. File ownership, who owns what? Every file and directory in Linux has an owner and a group. This is fundamental to the Linux security model. Owner. This is the user account that owns the file or directory. By default, when you create a file, you are its owner. Group. This is a group of users that share specific permissions for the file or directory. For example, multiple users in the web users group might need access to web files. To see who owns what, you use the lsl command, which we introduced in Chapter 3. Let's revisit it. Type lsl. You'll see output that looks something like this. Imagine the first part as a single line, then the owner and group names. RWRR1 username group name 1234 May 15/10/30 myfile.txt. In this example, the username field is the owner of the file. The group name field is the group that owns the file. Changing ownership, chown and chgrp. You can change the owner and/or group of a file or directory using chown change owner. You'll need sudo privileges to do this for files you don't own. To change the owner of a file, sudo chown new owner file name, read as sudo chown space new owner space file name. Example, sudo chown john report.txt. To change the group of a file, sudo chgrp new group file name, read as sudo chgrp space new group space file name. Example, sudo chgrp developers report.txt. To change both owner and group at once, sudo chown new owner new group file name, read as sudo chown space new owner new group space file name. Example, sudo chown john developers report.txt. To change ownership recursively for a directory and all its contents, sudo chown r new owner new group directory name / read as sudo chown space -r space new owner new group space directory name / File permissions, fine-grained control. Linux uses a system of permissions to control who can read, write, or execute a file. These permissions are assigned to 3 categories of users. Owner, the user who owns the file. Group, users who belong to the file's primary group. Others, all other users on the system. And there are 3 types of permissions. read, for a file, allows reading the contents of the file. For a directory, allows listing the contents of the directory, seeing what files are inside. write, for a file, allows modifying or deleting the file. For a directory, allows creating, deleting, or renaming files within that directory. Execute, for a file, allows running the file as a program if it's an executable script or binary. For a directory, allows entering the directory. The cd command requires execute permission. These permissions are displayed as a string of 10 characters at the beginning of the lsl output. Let's break it down. rwxrw, r. The first character indicates the file type. Hyphen means it's a regular file. D means it's a directory. There are other types, but these are the most common. The next 9 characters are grouped into 3 sets of 3. First set, rwx, permissions for the owner. Second set, rw, permissions for the group. Third set, r, permissions for others. Within each set, r means read, w means write, x means execute. A hyphen means the permission is denied. So rwxrwr means it's a regular file. The owner can read, write, and execute. The group can read and write but not execute. Others can only read. Changing permissions, chmod. You change file permissions using the chmod change mode command. There are 2 common ways to specify permissions: symbolic mode and octal numeric mode. 1. Symbolic mode. This method uses symbols to add plus, remove, or set equals permissions for specific user categories. U for owner, G for group, O for others, A for all. chmod U plus X file name, read as chmod space U plus X space file name, give the owner execute permission. chmod GW file name, remove write permission for the group. chmod O equals R file name, set read-only permission for others. chmod A plus RW file name, give read and write permission to all owner, group, others. 2. Octal numeric mode. This method assigns a numerical value to each permission. R read equals 4. W write 2. X execute equals 1. No permission equals 0. You sum these values for each category, owner, group, others to get a 3-digit number. 7 4 plus 2 plus 1 equals RWX read, write, execute. 6 4 plus 2 plus 0 equals RW read, write, no execute. 5 4 plus 0 plus 1 equals RX read, no write, execute. 4 4 plus 0 plus 0 equals R read only. 0 0 plus 0 plus 0 equals no permissions. Common examples: chmod 755 file name, owner, 7 RWX, group 5 RX, others 5 RX. This is a common permission for executable scripts and directories. It allows the owner full control, and others can read and execute or traverse in case of a directory. chmod 644 file name, owner, 6rw. Group 4r. Others, 4r. This is a common permission for regular files, e.g., text files, web pages. It allows the owner to read and write, and others to only read. chmod 700 directory name, owner, 7rwx. Group, others, 0. This makes a directory private to its owner. Just like chown, you can use the R option with chmod to apply changes recursively to a directory and its contents. Sudo chmod r 755 myapplication/. Special permissions, briefly. Beyond the standard RWX, there are special permission bits. setuid, set user ID. On an executable file, causes the file to be executed with the permissions of the owner of the file, rather than the user executing it. Often represented by s in the owner's execute spot. setgid, set group ID. Similar, but sets the group ID of the process to the group of the file. On a directory, new files created in it inherit the group of the directory, not the creating user's primary group. Represented by s in the group's execute spot. Sticky bit. On a directory, it restricts file deletion. Only the owner of a file or the directory owner, or root, can delete or rename files in that directory, even if they have write permission. Represented by a T in the other's execute spot. The /tmp directory often has the sticky bit set, and it's useful for shared directories where users shouldn't delete each other's files. You'll encounter special permissions less frequently unless you're managing complex multi-user environments or writing system-level programs. For daily administration, understanding RWX and chown/chmod is paramount. Storage management, disks and file systems. Beyond files and permissions, understanding how your server utilizes its disk storage is essential. Partitions. A physical disk is typically divided into one or more partitions. Each partition can then hold a file system. File systems. A file system is the structure that the operating system uses to organize and store files on a storage device, like an ext4 file system, common on Linux. Mounting. Before a file system on a partition can be used, it must be mounted at a specific point in the Linux directory tree. For example, your main Ubuntu file system is mounted at the root. Other partitions might be mounted at home/var or other custom locations. Checking disk space, df and do. df disk free shows the amount of free and used disk space for mounted file systems. dfh, read as, df space -h, displays output in a human-readable format, e.g., G for gigabytes, M for megabytes. This command is vital for quickly checking if a partition is running out of space, which can cause system instability. Do disk usage shows the disk usage of files and directories, useful for finding what's consuming space. Do sh path to directory, read as, du space -sh space /path/ to /directory. Summarizes the total size of a directory in human-readable format. Do h max depth equals 1 path to directory. Shows the size of immediate subdirectories, allowing you to drill down into space usage. Persistent mounts, etc. /fstab. When your system boots, it needs to know which file systems to mount and where. This information is stored in the etc. /fstab file, read as /etc. /fstab. Each line in this file describes a file system that should be mounted. Caution. Editing etc. /fstab incorrectly can prevent your system from booting. Always make a backup before editing. Sudo cp etc. /fstab etc. /fstab back. You'll likely use nano to edit this file. Sudo nano etc. /fstab. A typical line in etc. /fstab looks like this. Device identifier mount point file system type options dump fsc quarter. Device identifier. How the system identifies the partition, e.g., by UUID or device name like dev/sdb1. Using UUID, Universal Unique ID, is safer as it's persistent even if drive order changes. Mount point, where in the directory tree the file system will be mounted, e.g., home/var. File system type. The type of file system, e.g., ext4, xfs, ntfs. Options. Various mount options, e.g., defaults, no time, row for read-only. Dump, used by old backup utilities, typically 0. FSCK order, determines the order in which file systems are checked for errors at boot. 0 means no check. Root file system is usually 1, others 2. After editing etc/fstab, instead of rebooting, which is risky if there's an error, you can test your changes by running sudo mount a read as sudo mount space -a. If there are no errors, the file system should remount according to your new configuration. Understanding the Linux file system, ownership, and permissions is crucial for managing your server securely and efficiently. It's the foundation for installing software, configuring services, and troubleshooting issues. In the next chapter, we'll build on this by exploring how to monitor your server's performance and understand its various logs. Chapter 7. Keeping an eye on things, monitoring and logging. Imagine your Ubuntu server as a complex machine, like a high-performance vehicle. Just as a car has a dashboard to show you its speed, fuel level, and engine temperature, and a service log to record maintenance and issues, your server needs similar tools. Monitoring and logging are those essential tools for server administration. They allow you to understand how your server is performing, identify potential problems before they escalate, and diagnose issues when they arise. Performance monitoring tools, your server's dashboard. These commands provide real-time or snapshot views of your server's resource utilization, such as CPU, memory, and disk space. Top table of processes. This is your primary real-time performance monitor. When you type top, you'll see a dynamically updating list of the processes running on your server, along with summary information at the top. How to use. Simply type top, read as TOP, and press enter. Key metrics to look for. CPU usage, shown as percentages US for user processes, C for kernel, ID for idle. High US or C indicates a busy CPU. Memory usage. Displays total memory, used, free, and swap space. Keep an eye on free memory and how much swap space is being used. Excessive swap usage, which means data is being moved to disk because RAM is full, often indicates a memory bottleneck. Load average. 3 numbers representing the average number of processes waiting for CPU time over the last one, 5 and 15 minutes. For a single-core CPU, numbers consistently above 1.0 indicate possible overload. For multi-core CPUs, divide the load average by the number of CPU cores. Process list. Below the summary, you'll see a list of processes sorted by CPU usage by default. This helps you identify which applications or services are consuming the most resources. To quit top, simply press the Q key. HTOP, enhance top. While top is powerful, HTOP offers a more user-friendly and visually appealing interface. It provides color-coded output, uses a progress bar for CPU and memory usage, and allows for easier sorting and filtering of processes. Installation. HTOP is not always pre-installed. If you get a command not found error, you can install it easily. Sudo apt install htop. Read as sudo apt install htop. Once installed, just type htop and press enter. It offers similar metrics to top but in a clearer layout and lets you use the mouse, if your terminal supports it, or function keys for interaction. Press Q to quit. Free display memory usage. For a focused view on memory, the free command is invaluable. How to use. Free H, read as free space -H. The H option makes the output human-readable, e.g. in gigabytes. Output columns, total. Total memory available. Used, memory currently in use. Free, unused memory. Shared, memory shared by multiple processes. Buff cache, memory used for buffering and caching, which Linux uses to speed up disk operations. This memory is actually available for applications if needed. Available, an estimate of how much memory is available for starting new applications without swapping. This is usually the most important number to monitor. Swap. Information about your swap space, disk space used as a temporary extension of RAM. DF, disk free, and do disk usage. You were introduced to these commands in Chapter 6 for checking disk space. In terms of monitoring, df is used to quickly check if any of your mounted file systems are running critically low on space. A full disk can lead to catastrophic server failures. dfh, read as df space -h to see a summary of all mounted file systems. Do helps you investigate which files or directories are consuming the most space. If df reports a partition is almost full, do is your next tool to recursively check directory sizes until you find the culprit. Do sh var/log, read as du space -sh space /var/log to get a summary of a specific directory's size. Logging, the server's diary. Every action, error, and event on your server is meticulously recorded in log files. These logs are the server's indispensable diary, providing a historical record that is crucial for troubleshooting, security auditing, and understanding system behavior. Log file location. On Ubuntu and most Linux systems, the vast majority of system and application logs are stored in the /var/log directory. We briefly mentioned this in Chapter 6. Common log files in var/log, syslog. General system activity, including messages from the kernel and various services. This is a very broad log. Authlog records authentication events such as login attempts, both successful and failed, sudo usage, and SSH connections. In Chapter 4, if you encounter SSH login issues, this is one of the first places to look. Kernlog messages from the Linux kernel related to hardware, device drivers, and system core operations. Application-specific logs. Many applications, especially web servers and databases, create their own subdirectories within var/log for their specific logs. For example, Apache web server logs are typically found in var/log/apache2/, often containing access log, who accessed your website, and error log, web server errors. Monitoring live logs with tailf. As discussed in Chapter 3, the tailf command lets you follow a log file in real time. New lines that are added to the log will appear instantly on your screen. This is incredibly useful when troubleshooting an active issue. Example: to watch new system messages as they happen, tailf var/log/syslog, read as tail space -f space /var/log/syslog. Press Ctrl+C to stop following. Example: to see web server access in real time, tailf var/log/apache2/accesslog. Journoctil, the modern Linux log viewer. Modern Linux systems, including Ubuntu, use systemd read as. Systemd for managing services and processes. Systemd centralizes logging from various sources into a unified system called the journal. The journoctil read as. Journal control command is your primary tool for querying and viewing this journal. Journoctil is like a super-powered log viewer that can filter, order, and present logs from across your system. View all logs. Simply type journoctil. This will display all log entries from the earliest available. Use the arrow keys to scroll, press page up or page down, and Q to quit. View logs for the current boot. Journoctil B, read as. Journal control space -b. This is very useful for troubleshooting issues that occurred since the last server reboot. View logs in reverse order, newest first. Journoctil R, read as. Journal control space -r. View live logs similar to tailf. Journoctil F, read as, journal control space -f. Filter by service unit. One of Journoctil's most powerful features is filtering by specific systemed units, services. To view logs for the SSH service. Journoctil U SSH service, read as, journal control space -u space ssh.service. To view logs for the Apache web server. Journoctil U Apache2 service. Filter by time, since a specific date and time. Journoctil since 2023 to 10 to 27 15:30. Since a relative time. Journoctil since today, or Journoctil since yesterday, or Journoctil since 1 hour ago. Combined with an until clause. Journoctil since 2 hours ago until 1 hour ago. Filter by priority. Log messages have priority levels: debug, info, notice, warning, error, critical, alert, emergency. To see only error messages. Journoctil PR, read as, journal control space -p space ERR. To see messages with priority warning or higher. Journoctil P warning. Kernel messages, to view only messages from the kernel. Journoctal K, read as journal control space -K. Practical troubleshooting with logs. When something goes wrong on your server, logs are your best friend. Here's a typical troubleshooting approach. Check immediate system status. Use top or htop to see if CPU, memory, or specific processes are overloaded. Use df/h to check disk space. Identify the affected service. Is it your web server, your database, SSH? Consult Journoctal for the service. Use Journoctal your service name service and look for error messages around the time the problem occurred. Combine with time filters like since for efficiency. Check application-specific logs. If Journoctal doesn't provide enough detail, look directly in /var/log/ your application name /. For example, for Apache, check var/log/apache2/error log. Look for recent authentication issues. If an application or service is failing to connect, check authlog or Journoctal SSH service for failed login attempts or permission issues. Regularly reviewing logs, even when things are working fine, can help you spot minor issues before they become major problems, or identify unusual activity that might indicate a security concern. Monitoring and logging are not just about fixing problems, they are about understanding your server's health and ensuring its continued smooth operation. In our next adventure, we'll move from monitoring to building by setting up a web server. Chapter 8, Serving the Web, Apache Nginx and your first website. Your server is installed, secured, and you know how to navigate its depths and manage its processes. Now, it's time to make your server truly serve. One of the most common and powerful uses for a server is to host websites, making them accessible to anyone with an internet connection. In this chapter, we'll explore the fundamentals of web serving and guide you through setting up your first website using either Apache or Nginx, the two most popular web server software packages in the world. What is a web server? At its core, a web server is a program that waits for incoming requests from web browsers, like Chrome, Firefox, or Safari, processes those requests, and then sends back the requested web pages or other content. When you type a website address, like example.com, into your browser sends a request to the server hosting that website. The web server on that machine receives the request, finds the correct files, HTML, CSS, JavaScript, images, and transmits them back to your browser, which then displays the page. Choosing your web server, Apache or Nginx. Both Apache and Nginx, pronounced Nginx, are excellent choices for hosting web content, and both are widely used. They have different architectures and excel in different areas. Apache HTTP Server, often referred to simply as Apache. It's the older, more established, and very flexible web server. It's known for its powerful htaccess file system, which allows website owners to configure features like URL rewriting and password protection within their website directories without needing central server access. Apache is highly modular and has a vast ecosystem of modules for almost any need. Nginx gained popularity more recently, particularly for its efficiency and speed, especially when handling a large number of concurrent connections. Nginx is excellent as a static content server and a reverse proxy, meaning it can sit in front of more complex applications, directing traffic efficiently. It's often favored for high-traffic websites. For most beginner and moderate uses, either server will perform admirably. We'll show you how to set up both, but for your first website, you might choose one to focus on. Setting up a website with Apache HTTP Server. Let's start with Apache. Install Apache. First, ensure your package lists are updated, then install the Apache 2 package. Type sudo apt update. Type sudo apt install Apache 2, read as sudo apt install Apache 2. During installation, Apache should start automatically. Verify Apache is running. You can check the status of the Apache service using systemctl. Type systemctl status Apache 2, read as system control status Apache 2. You should see active running in the output. Press Q to exit the status view. Adjust the firewall UFW. Remember how we set up UFW in Chapter 4? By default, your server's firewall will block incoming web traffic. Apache registers profiles with UFW that make it easy to open the necessary ports. Type sudo ufwa applist, read as sudo UFW applist to see available profiles. You should see Apache, Apache Full, and Apache Secure. Apache opens port 80 HTTP traffic unencrypted. Apache Secure opens port 443 HTTPS traffic encrypted. Apache Full opens both port 80 and port 443. For a simple website, let's open both HTTP and HTTPS. Type sudo ufwa allow Apache Full, read as sudo UFW allow Apache Full . Verify the rules. Sudo ufwa status, and you should see rules for ports 80 and 443 listed as allow. Test in your web browser. Open a web browser on your local computer and enter your server's IP address. For example, if your server's IP is 192.168.1.100, type http 192.168.1.100. Read as http://192.168.1.100 into the address bar. You should see the default Apache 2 Ubuntu default page. This confirms your web server is serving content. Hosting your first website, Apache Virtual Hosts. By default, Apache serves files from /var/www/html. This is fine for a single, basic website. However, to host multiple websites or to organize your projects better, Apache uses virtual hosts. A virtual host allows a single server to host multiple domain names, e.g., example.com and miblog.org, on the same IP address. Let's set up a new virtual host for a fictional domain, mywebsite.example.com. Create a new document root directory. This is where your website's files will live. It's often good practice to create a directory structure like /var/www/yourdomainname/publishmol. Type sudo mkdir p/var/www/mywebsite.example.com/publishmol. Read as sudo makedir --p /var/www/mywebsite.example.com/public_html. Set permissions important. The web server, Apache, needs read access to these files, but you, as the user, need full control. We'll assign ownership of the document root to your user and the web server group, www.data, and ensure appropriate file permissions. Type sudo chown ruser $user var/www/mywebsite.example.com. Read as sudo chown -r $user $user /www/mywebsite.example.com. The user variable automatically expands to your current username. Type sudo chmod r755 /var/www/mywebsite.example.com. Read as sudo chmod -r /755 /var/www/mywebsite.example.com. This gives the owner, you, read, write, and execute permissions, and group others read and execute. Create a simple HTML page. Let's make a basic index.html file for your new site. Type nano/var/www/mywebsite.example.com/publishmol/index.html. Read as nano//www/mywebsite.example.com/public_html/index.html. Paste the following content into the file. diocitoip HTML. HTML. Head. Title my first server website, /title. Head. Body. H1 hello from my awesome Ubuntu server, /h1. P if you're seeing this, your Apache web server is working P. Body. HTML. Press Ctrl+X then Y, then enter to save and exit. Create the Apache virtual host configuration file. Apache stores virtual host configurations in etc. Apache 2 sites available type. Sudo nano etc. /Apache 2 /sites available /mywebsite.example.com.conf. Read as sudo nano space slash etc slash apache2 slash sites available slash mywebsite.example.com.conf. Add the following configuration. This tells Apache to listen for requests from mywebsite.example.com and serve files from the directory you just created. Virtual host 80, server admin webmaster at localhost, server name mywebsite.example.com, document root /var/ www/mywebsite.example.com/publishmal, directory /var/ www/mywebsite.example.com/publishmal. Options indexes follow symlinks. Allow override all. Require all granted. Directory. Error log, Apache log dir /error log. Custom log, Apache log dir /access log combined. Virtual host. Press Ctrl X, then Y, then enter to save and exit. Enable the new virtual host and disable the default site. Apache provides utilities to enable and disable sites. Enable your site. Sudo a2n site mywebsite.example.com.conf. Read as sudo a2n site space mywebsite.example.com.conf. Disable the default Apache welcome page. Sudo a2disite 0-default.conf. Read as sudo a2disite space 000-default.conf. Test configuration and restart Apache. Always test your Apache configuration before restarting to catch errors. Type sudo apache-to-ctl config-test. Read as sudo apache-to-control config-test. You should see syntax OK. If not, recheck your configuration file for typos. Restart Apache to apply changes. Sudo systemctl restart apache2. Map the domain name, important DNS step. For mywebsite.example.com to point to your server, you need to configure your domain name system, or DNS, records. For local testing, if you don't own a domain name, you can temporarily modify your computer's hosts file. On Linux and macOS, it's typically etc. hosts. On Windows, it's c/Windows/system 32/drivers/etc/ hosts. Add a line like your server at mywebsite.example.com. Replace your server with your server's actual IP address. For a public website, you would log into your domain registrars, like GoDaddy, Namecheap, or DNS provider's control panel, and create an A record that points mywebsite.example.com to your server's public IP address. DNS changes can take a few hours to propagate globally. Browse your new site. Now, open your web browser and navigate to http://mywebsite.example.com. You should see your custom "Hello from my awesome Ubuntu server" page. Congratulations, setting up a website with Nginx. If you prefer Nginx, here's how to set up a similar website. You would typically choose either Apache or Nginx, not both, for a single web server role on a beginner server to avoid complexity and potential port conflicts. Install Nginx. Update your package lists and install Nginx. Type sudo apt update. Type sudo apt install Nginx. Read as sudo apt install Nginx. Nginx should start automatically after installation. Verify Nginx is running. Check the service status. Type systemctl status Nginx. Read as system control status Nginx. You should see active running. Press Q to exit. Adjust the firewall UFW. Nginx also registers UFW profiles. Type sudo ufwa applist. Read as sudo UFW applist to see Nginx, Nginx full, and Nginx secure. Allow both HTTP and HTTPS. Sudo ufwa allow Nginx full. Read as sudo UFW allow Nginx full . Verify sudo ufwa status. Test in your web browser. Navigate to your server's IP address, e.g., http 192.168.1.100. You should see the default Welcome to Nginx page. Hosting your first website, Nginx server blocks. Nginx uses server blocks, which are analogous to Apache's virtual hosts, allowing you to host multiple domain names. Let's set up a server block for mywebsite.example.com with Nginx. Create a new document root directory. Similar to Apache, create the directory for your website files. Type sudo mkdir p/var/www/mywebsite.example.com/publishmal. Read as sudo make dir space hyphen p space slash var slash www slash mywebsite.example.com slash public underscore HTML. Set permissions important. Type sudo chown ruser $user var slash www slash mywebsite.example.com. Read as sudo chown space hyphen r space $user $user space slash var slash www slash mywebsite.example.com. Type sudo chmod r755 slash var slash www slash mywebsite.example.com. Read as sudo chmod space hyphen r space 755 space slash var slash www slash mywebsite.example.com. Create a simple HTML page. Type nano slash var slash www slash mywebsite.example.com slash publishmol slash index.html. Read as nano space slash var slash www slash mywebsite.example.com slash public underscore HTML slash index.html. Add the same HTML content as before. Diositoip HTML. HTML. Head. Title my first server website slash title. Head. Body. H1 hello from my awesome Ubuntu server slash H1. P if you're seeing this, your Nginx web server is working P. Body. HTML. Save and exit Ctrl+X Y enter. Create the Nginx server block configuration file. Nginx server blocks are typically configured in etc slash nginx slash sites available slash. Type sudo nano etc slash nginx slash sites available slash mywebsite.example.com. Read as sudo nano space slash etc slash nginx slash sites available slash mywebsite.example.com. Add the following configuration. Server, listen 80, listen, 80. Root slash var slash www slash mywebsite.example.com slash publishmol. Index index.html index.htm. Server name mywebsite.example.com www.mywebsite.example.com. Location trifles yuri slash equals 404. Error log slash var slash log slash nginx slash mywebsite.example.com log warn. Access log var slash log slash nginx slash mywebsite.example.com access log. The listen 80. Directives tell nginx to listen for HTTP requests on port 80. Root points to your website's document root. Index defines the order of default files to look for, e.g., index.html first. Server name specifies the domain names this block applies to. Location slash handles requests for files within the root directory. Error log and access log define specific log files for this website. Save and exit Ctrl+X Y enter. Enable the new server block and disable the default site. Nginx uses symlinks, symbolic links, from sites available to sites enabled. Type sudo lns etc slash nginx slash sites available slash mywebsite.example.com etc slash nginx slash sites. Enabled. Read as sudo ln space hyphen s space slash etc slash nginx slash sites available slash mywebsite.example.com space slash etc slash nginx slash sites enabled slash. Remove the default link. Sudo rm etc slash nginx slash sites enabled slash default. Read as sudo rm space slash etc slash nginx slash sites enabled slash default. Test configuration and restart nginx. Type sudo nginx t. Read as sudo nginx space hyphen t. You should see syntax is okay and test is successful. Restart nginx to apply changes. Sudo systemctl restart nginx. Map the domain name, important DNS step. As with Apache, configure your DNS records, or hosts file for local testing, to point mywebsite.example.com to your server's IP address. Browse your new site. Open your web browser and go to http mywebsite.example.com. You should see your custom Nginx web page. You've now successfully configured your Ubuntu server to host a website. Whether you chose Apache or Nginx, you've taken a significant step toward making your server a truly functional platform for your projects. In the next chapter, we'll turn our attention to storing and managing data by setting up a powerful database server. Chapter 9, Data Powerhouse. Setting up databases with MySQL/PostgreSQL. So far, your Ubuntu server can act as a web host, delivering static content and handling requests. But what if your website needs to store information, like user accounts, product lists, blog posts, or customer data? This is where a database server comes in. A database is an organized collection of data, and a database server is the software that manages this data, allowing applications to store, retrieve, update, and delete information efficiently and reliably. Most dynamic websites, from small blogs to large e-commerce platforms, rely on a database. For instance, if you're running a WordPress blog, your posts, comments, user information, and settings are all stored in a database. When a visitor loads a page, the web server, Apache or Nginx, communicates with the database server to fetch the specific content for that page. Relational databases. MySQL and PostgreSQL. The most common type of database for web applications is a relational database. It organizes data into tables, with rows and columns, similar to a spreadsheet, allowing data to be linked between different tables. Two of the most popular open-source relational database management systems, RDBMS, are MySQL and PostgreSQL. MySQL. MySQL is arguably the most widely used open-source database. It's known for its speed, ease of use, and compatibility with a vast range of applications and programming languages. It's the M in the popular LAMP, Linux, Apache, MySQL, PHP, and LEMP Linux, Nginx, MySQL, PHP stacks. Many content management systems, like WordPress, Drupal, Joomla, default to MySQL. PostgreSQL. PostgreSQL is often considered a more advanced and feature-rich database compared to MySQL, sometimes called the developer's database. It adheres more strictly to SQL standards and offers more advanced data types and transactions. It's known for its robustness, reliability, and emphasis on data integrity. While it might have a slightly steeper learning curve for absolute beginners, it's an excellent choice for complex applications where data consistency is paramount. For this guide, we'll focus on setting up MySQL, given its widespread popularity and suitability for a broad range of web applications. The concepts of creating databases, users, and giving permissions are similar across both systems. Setting up MySQL on Ubuntu Server. Let's turn your server into a data powerhouse. Install MySQL Server. First, update your package lists, then install the MySQL Server package. Type sudo apt update. Type sudo apt install MySQL Server. Read as sudo apt install MySQL Server. During the installation, you might not be prompted to set a root password immediately, as modern Ubuntu versions handle some security configurations differently. Run the MySQL security script. After installation, it's crucial to run a security script that comes with MySQL. This script helps you secure your database installation by setting a root password, removing insecure default users, and configuring other security best practices. Type sudo mysql secure installation. Read as sudo MySQL secure installation. You'll be guided through several prompts. Validate password component. This allows you to enforce strong passwords. You can choose to set it up, press Y for yes, and then select a strength level 0 for low, 1 for medium, 2 for strong. For beginners, you might start with 0 or 1, but in production, 2 is highly recommended. You'll then be asked to set a password for the MySQL root user. Note, this root user is for MySQL database administration, separate from your Ubuntu system's root user. Remove anonymous users. Press Y. Anonymous users are a security risk as they don't require a password. Disallow root login remotely. Press Y. It's best practice to allow the MySQL root user to connect only from the local server. This prevents attackers from trying to guess your root password over the network. Remove test database and access to it. Press Y. The test database is for testing purposes and should not be present on a production server. Reload privileged tables now. Press Y. This applies the changes you've just made. Once this script finishes, your MySQL installation is much more secure. Basic MySQL commands. Accessing the prompt. To interact with MySQL and create databases, you'll use the MySQL command line client. To log in as the MySQL root user from your server's terminal, sudo mysql read as sudo mysql. This logs you in using your system's sudo privileges directly to the MySQL root, typically without requiring the MySQL root password you just set. This is a common and secure way to administer MySQL locally on Ubuntu. You'll know you're in the MySQL prompt because it changes from $to MySQL. Creating a new database. Most applications use their own dedicated database. Let's create one for a hypothetical web application called MyWebAppDB. At the MySQL prompt type, create database MyWebAppDB, read as create database mywebapp_db. You should see query OK, one row affected if successful. Creating a new database user and granting permissions. It's a security best practice never to use the MySQL root user for your applications. Instead, create a dedicated user for each application, granting it only the specific permissions it needs on its specific database. Create the user web user that can connect only from the local server localhost and give it a strong password. Type create user web user at localhost, identified by your super strong password here. Read as create user web user at localhost, identified by your super strong password here exclamation mark semicolon. Remember to replace your super strong password here with an actual strong unique password. Now grant this web user all privileges specifically on the MyWebAppDB database. Type grant all privileges on MyWebAppDB to web user at localhost. Read as grant all privileges on mywebapp_db. To web user at localhost semicolon. The means all tables within that specific database. Reload MySQL's privilege tables so the changes take effect. Type flush privileges, read as flush privileges semicolon. Exit the MySQL prompt, type exit, read as exit semicolon. You now have a MyWebAppDB database and a web user that can access and manage everything within it, but only from the application running on the same server. Adjust the firewall UFW for remote access optional and with caution. By default, MySQL is configured to listen only for connections from localhost, the server itself. This is the most secure configuration, and for most web applications where the database and web server are on the same machine, it's sufficient. However, if you needed to connect to your MySQL database from another machine on your local network or from a different server, you would need to allow the MySQL port through the firewall. Type sudo ufwa allow MySQL, read as sudo ufw allow MySQL, or sudo ufwa allow 3306, port 3306. Configure MySQL to listen on external interfaces. This requires editing the MySQL configuration file. Type sudo nano etc /mysql/mysql.confd/misql.cnf, read as sudo nano space / etc /mysql/mysql.conf.d/mysqld.cnf. Find the line bind address equals 127.0.0.1. Change 127.0.0.1 to 0.0.0.0 to listen on all interfaces, or, preferably, to your server's specific local network IP address to restrict it. Save and exit Ctrl+X+Y, enter. Restart MySQL, sudo systemctl restart MySQL, read as sudo systemcontrol restart MySQL. Warning: opening MySQL to the public internet is a significant security risk. If you absolutely must access it remotely, use a virtual private network, VPN. Strictly limit access by IP address in UFW, sudo ufwa allow from your emotip to any port 3306, and ensure your database users have strong passwords and limited privileges. For learning, sticking to localhost binding is safest. Test the new user optional. You can test your newly created web user from the command line. Type MySQL u web user p, read as MySQL space -u space web user space -p. You'll be prompted for web user's password. Enter it. Once logged in, verify you can access your database. Show databases. Read as show databases semicolon. You should see MyWebAppDB listed. Try switching to it. use mywebAppDB, read as use mywebapp_db. Then try a simple command to confirm, show tables, read as show tables. It will likely be empty as there are no tables yet. Type exit to leave the prompt. You now have a fully functional MySQL database server installed and configured with a new database and a dedicated user. Your web applications can now connect to this database, mywebAppDB, using the web user credentials to store and retrieve their dynamic content. This opens up a whole new world of possibilities for what your Ubuntu server can host. In the next chapter, we'll explore another common server function, sharing files across your network. Chapter 10, Sharing is Caring, File Services with Samba and NFS. Your Ubuntu server is becoming quite the workhorse. It can host websites and manage databases. But servers aren't just for serving web content, they're also excellent for sharing files. Imagine a central location where all your family photos, work documents, or media files are stored, accessible from different devices on your network, or a server that needs to provide shared storage to other Linux machines. This is where file services come in. In this chapter, we'll explore how to turn your Ubuntu server into a powerful file server using two key technologies: Samba for sharing files with Windows computers, and NFS, Network File System, for sharing files with other Linux Unix machines. Understanding file sharing. At its core, file sharing means allowing multiple users or computers on a network to access and often modify files stored on a central server. This provides benefits like centralized storage, no more searching for files across different devices; data backup, easier to back up content from a single location; collaboration, multiple users can work on the same documents; resource sharing, allows applications to access shared data, sharing with Windows clients; Samba. Samba is an open-source software suite that provides file and print services to SMBCIFS clients, which is the protocol used by Windows for file sharing. Essentially, Samba makes your Linux server look and act like a Windows file server to Windows machines. Setting up a basic Samba share. Let's set up a shared folder on your Ubuntu server that can be accessed by your Windows computer. Install Samba. First, update your package list, then install the Samba package. Type sudo apt update. Type sudo apt install Samba. Read as sudo apt install Samba. Create a directory to share. Let's create a shared directory for general purpose files, perhaps for your users to store documents and media. Type sudo mkdir p srv/samba/mishare. Read as sudo makedir space -p space /srv/samba/myshare. This path follows a common convention for service data in /srv, as discussed in Chapter 6. Set permissions for the shared directory. For a general share, you might want multiple users to be able to read and write. We'll set the directory to be owned by the root user, but allow group written access. Type sudo chown r root sambashare /srv/samba/mishare. Read as sudo chown space -r space root sambashare space /srv/samba/myshare. We'll make sambashare a new group. Type sudo chmod r 2770 srv/samba/mishare. Read as sudo chmod space -r space 2770 space /srv/samba/myshare. The 2 sets the sgid bit, which ensures that new files created within this directory inherit the group ownership of the directory, in this case, SambaShare, making collaboration easier. The 770 gives the owner root and the group, SambaShare, full read, write, and execute permissions while denying access to others. Create the Samba users group. If it doesn't already exist, create the SambaShare group. Type sudo group add SambaShare, read as sudo group add space SambaShare. Add your system users to the Samba group and set Samba passwords. Any Linux user who needs to access the Samba share from a Windows machine must also be added to the Samba share group and have a Samba-specific password. Their Samba password doesn't have to be the same as their Linux password, but it often is. To add your primary user, e.g., your username, to the Samba share group, type sudo usermod ag Samba share your username, read as sudo usermod space -a g space sambashare space your username. To set a Samba password for this user, type sudo smb password a your username, read as sudo smb password space, hyphen a space your username. You'll be prompted to enter and confirm a new Samba password for this user. Configure the Samba share. Samba's main configuration file is smb.conf. Always make a backup before editing. Type sudo cp etc slash samba slash smb.conf etc slash samba slash smb.conf back. Read as sudo cp space slash etc slash samba slash smb.conf space slash etc slash samba slash smb.conf.back. Open the configuration file for editing. Sudo nano etc slash samba slash smb.conf. Read as sudo nano space slash etc slash samba slash smb.conf. Scroll to the very end of the file and add the following section. This defines your new share, mishare. Comment equals my shared folder. Path srv slash samba slash mishare. Browsable equals yes. Guest OK equals no. Read only equals no. Create mask equals 770. Directory mask equals 2770. Valid users equals at samba share. Mishare. Name of your share, how it appears on Windows. Comment, a description of the share. Path, the absolute path to the directory you want to share. Browsable equals yes, makes the share visible when browsing network shares. Guest OK equals no. Prevents anonymous guest access, recommended for security. Read only equals no, allows users to write files to the share. Create mask equals 770 and directory mask equals 2770. Control file and directory permissions for new items created in the share. Ensuring files inherit the 770 RWX for owner group. No access for others, and directories inherit the 2770 SGID bit plus RWX for owner group, discussed earlier. Valid users equals at Samba share. Only users belonging to the Samba share group can access this share. Save and exit Ctrl+X, Y, enter. Adjust the firewall, UFW. Samba uses specific ports. You'll need to allow them through UFW. Type sudo ufware allow samba, read as sudo UFW allow samba. This opens ports 137, 138 UDP, and 139, 445 TCP. Verify sudo ufwa status. Restart Samba. Apply the changes by restarting the Samba service. Type sudo systemctl restart smbd nmbd, read as sudo system control restart smbd nmbd. SMBD handles the file sharing service. NMBD handles NetBIOS name resolution. Accessing the Samba share from a Windows client. Now from your Windows computer, open File Explorer. In the address bar, type //yourserverip/mishare, read as //your_server_IP/myshare, and press enter. You'll be prompted for a username and password. Use the Linux username, e.g., your username, and the Samba password you set for it earlier. You should now see the contents of your srv/samba/mishare directory. You can create files, folders, and move things around just like a local drive. Sharing with Linux Unix clients. Network File System, NFS. NFS is a native Linux Unix file sharing protocol. It allows you to mount a remote directory from your server onto another Linux machine as if it were a local directory. This is common in environments with multiple Linux servers that need to share data or configuration files. Setting up a basic NFS export. Let's say you want to share /var/www/html from your server with another Linux server that also hosts web content. Install NFS server components, type sudo apt update, type sudo apt install NFS kernel server, read as sudo apt install nfs-kernel-server. Create a directory to share or use an existing one. For this example, we'll use the Apache webroot from Chapter 8, /var/www/html. If you want a new dedicated share, you'd create mkdir p/srv/nfs/myotherdata. Adjust permissions for the NFS share. Ensure the directory you're sharing has the appropriate read-write permissions for the user's processes on the client machine that will access it. For /var/www/html, It usually has permissions suitable for the web server, which is often fine. Configure the NFS export. NFS exports are defined in the etc. exports file. Type sudo nano etc. exports. Read as sudo nano space slash etc. slash exports. Add a line at the end of the file defining your share. Replace 192.168.1.0/24 with the network range or specific IP address of your client's network. /var/www/html 192.168.1.0/24 rw sync /var/www/html. The directory on the server to be shared. 192.168.1.0/24 the allowed clients. This can be a specific IP, 192.168.1.101, a hostname, if DNS is set up, or a network range, as shown. RW sync /. Options for the share. RW allows read and write access. Use row for read-only. Sync responds to requests only after changes have been written to disk safer but potentially slower. /subtree prevents subtree checking, which can cause issues when a subdirectory is mounted and the parent directory is not exported. Generally recommended. Save and exit Ctrl+X Y enter. Export the shares. Tell the NFS server about the new exports. Type sudo exportfs read as sudo exportfs space -a. To verify the exported shares, sudo exports. Adjust the firewall, UFW. NFS uses several ports. UFW has a profile for it. Type sudo ufware allow NFS, read as sudo UFW allow NFS. Or, if you want to restrict it to specific clients, sudo ufware allow from 192.168.1.101 to any port NFS. Verify sudo ufware status. Restart NFS server. Type sudo systemctl restart NFS kernel server. Read as sudo systemcontrol restart NFS -kernel -server. Accessing the NFS share from a Linux client. From your client Linux machine, the one that needs to access the share. Install NFS client components. Type sudo apt update. Type sudo apt install NFS common. Read as sudo apt install NFS -common. Create a mount point. This is where the remote directory will appear on your client machine. Type sudo mkdir p/mnt/webshare. Read as sudo makedir space -p space /mnt/webshare. Mount the NFS share. Type sudo mount your server ip /var/www/html/mnt/webshare. Read as sudo mount space your _server _ip :/www/html space /mnt/webshare. Replace your server ip with your server's actual IP address. Verify the mount. Type dfh read as df space -h. You should see a line showing your server's IP mounted at /mnt/webshare. Type ls/mnt/webshare. Read as ls space /mnt/webshare to see the files. Make the mount persistent, optional. To have the NFS share automatically mount every time the client machine reboots, add an entry to the client's etc/fstab file as discussed in Chapter 6. Type sudo nano etc/fstab. Add a line like this at the end. Your server ip /var/www/html/mnt/webshare NFS default 00. Save and exit. Test the mount with sudo mount a, read as sudo mount space -a. By implementing Samba and/or NFS, you've added essential file sharing capabilities to your Ubuntu server, making it a truly central hub for your network's data. This allows for easier collaboration, centralized storage, and simplified backup strategies. In the next chapter, we'll continue to expand your server's utility by exploring automation, backup strategies, and recovery plans. Chapter 11, Beyond the Basics, Automation, Backups, and Recovery. Congratulations, you've come a long way. Your Ubuntu server is installed, secured, capable of hosting websites, running databases, and sharing files. At this point, you're managing a significant amount of functionality. But what happens when you're not actively issuing commands? How do you ensure tasks run reliably? And what if something goes wrong, truly wrong, like a hard drive failure? This chapter shifts our focus to automating repetitive tasks, establishing robust backup strategies, and understanding the critical steps for recovery. The power of automation. Cron and shell scripting. As an administrator, your time is valuable. Many tasks, such as system updates, log rotation, or generating reports, are repetitive. Automating these tasks ensures they are performed consistently and frees you up for more complex work. Cron, your server's scheduler. Cron is a time-based job scheduler in Linux. It allows you to specify commands or scripts to run automatically at predetermined intervals. Every user, and the system itself, can have its own cron tab, short for cron table, which is a file containing a list of jobs to be executed. Editing your cron tab. To edit your personal cron tab, or create one if it doesn't exist, type cron tab e read as cron tab space -e. If prompted, choose nano as your editor. You'll see a file with comments explaining the format. Scroll to the end to add your entries. Cron tab syntax. Each line in your cron tab represents a job and has 5 time fields, followed by the command to execute. Minute hour day of month day of week command to execute. Minute 0 to 59. Hour 0 to 23. 0 is midnight. Day of month 1 to 31. Month 1 to 12, or Jan, Feb, etc. Day of week 0 to 7. 0 or 7 is Sunday. 1 is Monday. Asterisks are wildcards meaning every. Commas, separate multiple values, e.g., 115 for the 1st and 15th. Hyphens specify ranges, e.g., 9 to 17 for 9 a.m. to 5 p.m. / specifies step values, e.g., 5 for every 5 units. Let's look at some examples. Path to command. Runs every minute. Use with caution. 03/usr/bin/apt update. Runs apt update every day at 3 o'clock a.m. 001/path/to/month/backup/sh. Runs a script on the first day of every month at midnight. 020/usr/bin/reboot. Reboots the server every Sunday at 2 o'clock a.m. Use with extreme caution on production servers. Example. Daily system update via a simple script. You can put multiple commands into a shell script and schedule that script with cron. First, create a simple script, for example, update script sh in your home directory. Nano update script sh. Add the following lines: bin bash, sudo apt update, and in sudo apt upgrade y. Sudo apt auto remove y. Save and exit, make the script executable. chmod plus x update script sh, read as chmod plus x space ~update_script.sh. Now, schedule it with cron. Edit your cron tab E, and add 03/home/your username/update script sh. This runs every day at 3 o'clock a.m. Replace your username with your actual username. System-wide cron tab, /etc/cron-d and /etc/cron tab. For system-level tasks, you might see files in /etc/cron-daily, /etc/cron-weekly, /etc/cron-monthly, which automatically run scripts placed within them. You can also create dedicated cron files in /etc/cron-d, which requires specifying the user the command runs as, e.g., 03 root path to command. For an individual server, sticking to your user's cron tab or scripts within cron daily is often sufficient. Shell scripting, automating sequences. The example above demonstrated a simple shell script. Shell scripts are sequences of commands written in a text file that the shell, like bash, can execute. They are the backbone of Linux automation. Learning basic shell scripting, variables, loops, conditionals, can unlock immense power for automating complex tasks, from managing backups to deploying applications. Resources like Bash Scripting Tutorial can provide an excellent starting point for this skill. The indispensable art of backups. This is perhaps the most critical section for any server administrator. Backups. It's often said there are 2 types of people: those who back up their data and those who will back up their data. Data loss due to hardware failure, accidental deletion, cyberattack, or natural disaster is a matter of when, not if. Backup principles, the 3-2-1 rule. A good backup strategy adheres to the 3-2-1 rule: 3 copies of your data, the original and 2 backups. 2 different media types. For example, your server's disk and an external hard drive or cloud storage. 1 offsite copy. Store at least 1 backup copy in a different physical location to protect against local disasters, fire, flood, theft. What to backup? Application data, web files, /var/www or /srv/www, database dumps, user-uploaded content, configuration files, etc. directory, etc. This contains all your server's settings, SSH, Apache /Nginx, Samba, network, etc. Log files, /var/log can be useful for historical troubleshooting, but often less critical to restore immediately. User data, home if you have personal user files stored on the server. Backup tools and strategies. Tar Tape Archiver, archiving and compression. Tar is excellent for creating compressed archives of directories and files. Creating a compressed archive. Type: sudo tar cvpzf path / backup tar gz exclude / path / exclude one file system path / data backup. Read as sudo tar space -cvpzf space /path / backup tar gz space double hyphen exclude / path / exclude space double hyphen 1 hyphen file hyphen system space /path / data to backup. C. Create archive. V. Verbose show progress. P. Preserve permissions. Z. Compress with gzip. F. Specify archive file name. Exclude specific paths, e.g., temporary files, other backup directories to avoid recursive backups. One file system. Only backup files on the same file system. Important to prevent traversing into mounted external drives or other partitions you don't intend to back up together. Example, backup web server files and configs. Sudo tar cvpzf mnt /backup drive /webindex $. Date +%y%m%d. tar gz / exclude /var / www /html /wp content /cache / one file system / /var / www /html etc. This creates a gzip compressed tarball named with today's date, excluding a cache directory, backing up only HTML and etc. file systems, and storing it on a mounted backup drive. Extracting an archive. Type: sudo tar xvpzf path / backup tar gzc destination directory. Read as sudo tar space -xvpzf space /path / backup tar gz space -c space /destination /directory. XC. Extract. C. Change to specific directory before extracting. Database backups, MySQL /PostgreSQL. For databases, you don't just copy the files, you need to create a consistent dump of the database. MySQL, use miscldump. Type: sudo miscldump u root p mydatabase path / backup / mydatabase backup SQL. Read as sudo mysqldump space -u space root space -p space mydatabase space greater than space /path / backup /mydatabase _backup .sql. You'll be prompted for the MySQL root password. This creates a SQL file containing all the SQL commands needed to reconstruct your database. PostgreSQL, use pgdump. Type: sudo pgdump u postgres mydatabase path / backup /mydatabase backup SQL. Read as sudo pg_dump space -u space postgres space mydatabase space greater than space /path / backup /mydatabase _backup .sql. rsync, efficient synchronization. rsync is a powerful utility for synchronizing files and directories, locally or remotely. It's highly efficient because it only transfers the parts of files that have changed, making incremental backups very fast. Basic local backup. Type: rsync avs source directory destination directory. Read as rsync space -avz space /source /directory space /destination /directory. Say, archive mode preserves permissions, ownership, timestamps, symbolic links, etc. V. Verbose. Z. Compress during transfer. Saves bandwidth for remote transfers. Remote backup to another server accessible via SSH. Type: rsync avs source directory user at remote host /destination/directory. Read as rsync space -avz space /source/directory space user at remote_host:/destination/directory. Delete extraneous files, destination mirrors source. Type rsync avs delete source directory destination directory. Read as rsync space -avz space -delete space /source/directory space /destination/directory. Be extremely careful with delete. It will remove files from the destination if they no longer exist in the source. Test thoroughly before using in production. Recovery, testing your safety net. A backup is only as good as its ability to be restored. Testing your backups is non-negotiable. Many administrators have been devastated to discover their backups were corrupted or incomplete when they actually needed them. How to test a restore: extract files. Use tar or rsync to restore a few files, or even a whole small directory, to a different location than their original path on a test system, or in an isolated directory. Verify content. Check that the restored files are intact and readable. Database restore. If you're backing up databases, try restoring a miscldump file into a new, empty database. Never overwrite your live one without extreme caution and prior practice, and verify that the data is present and correct. Practice, periodically, simulate a disaster. Spin up a new virtual machine, perform a fresh Ubuntu server installation, and then attempt to fully restore your applications and data from your backups. This practice is eye-opening and reveals potential gaps in your strategy. Disaster recovery considerations. Bare metal recovery. More advanced methods like disk imaging, using tools like DD or specialized backup software, allow you to restore a complete snapshot of your entire server, including the operating system, to new hardware. Rebuild and restore. A common strategy is to perform a fresh installation of Ubuntu Server, secure it, reinstall necessary packages, Apache, MySQL, etc., and then restore your application data and configuration files from backup. This verifies your setup process and ensures you're not restoring hidden problems. Implementing a solid automation and backup strategy gives you peace of mind and is a hallmark of a professional server administrator. You are proactively protecting your server and its valuable data. In our final chapter, we'll look ahead to modern server technologies and future learning paths, helping you continue your journey in server administration. Chapter 12. The future is now. Virtualization, containers, and cloud considerations. Congratulations! From initial installation and security hardening to setting up web servers, databases, file shares, and implementing automation and robust backup strategies, you've gained invaluable skills in managing an Ubuntu server. You're now equipped with the foundational knowledge to confidently administer your own server and understand the core principles of Linux system administration. But the world of server technology is constantly evolving. While the skills you've learned are timeless and fundamental, the way we deploy and manage applications on servers has changed dramatically. This final chapter will provide a high-level overview of these modern paradigms: virtualization, containerization, and cloud computing, explaining how they build upon the concepts you've mastered and where your learning journey might take you next. The evolution of server deployment. Historically, each application, e.g., a web server, a database, an email server, often ran on its own dedicated physical machine. This was simple but incredibly inefficient, leading to underutilized hardware and high operational costs. 1. Virtualization, sharing the hardware, isolating the software. Virtualization was one of the first major revolutions, allowing multiple virtual machines, VMS, to run concurrently on a single piece of physical hardware. Each virtual machine acts like a completely separate computer, with its own operating system, like Ubuntu Server, CPU, memory, and disk space allocated by a hypervisor. How it works: a hypervisor, software like VirtualBox, VMware, or KVM, sits between the physical hardware and the operating systems running inside the virtual machines. It manages and allocates the underlying physical resources to each VM, ensuring they operate independently. Benefits: resource efficiency, maximizes hardware utilization. Isolation: VMS are isolated from each other. An issue in one typically won't affect another. Portability. VMS can often be easily moved between different physical hosts. Snapshots and rollbacks. You can take a snapshot of a VMS state and revert to it if something goes wrong, a fantastic tool for testing. Ubuntu's role. Ubuntu Server is a very popular choice for use inside virtual machines due to its efficiency and stability. It can also act as the host operating system for hypervisors like KVM, kernel-based virtual machine, making it a powerful platform for building your own virtualized environment. Next steps. If you want to explore this more, look into KVM and libvirt for setting up virtualization on your own hardware, or explore commercial hypervisors like VMware ESXi or Microsoft Hyper-V. 2. Containerization. Lighter, faster, more portable isolation. Building on the idea of isolation, containerization takes it a step further. Instead of virtualizing the entire operating system, containers virtualize the operating system layer. They share the host operating system's kernel, but contain all application-specific dependencies, libraries, binaries, configuration files in a lightweight, isolated package. How it works. Tools like Docker, the most popular container platform, allow you to package an application and its dependencies into a standard unit called an image. From this image, you can create containers, which are isolated, runnable instances of your application. Key differences from VMS. Lightweight. Containers start much faster and consume fewer resources than VMS because they don't have their own separate operating system kernel. Portability. A containerized application runs consistently across different environments, from your local machine to a cloud server, because all its dependencies are bundled with it. Scalability. Easier to scale applications by rapidly deploying many identical containers. Ubuntu's role. Ubuntu Server is a first-class citizen in the container world. It's an excellent host for running Docker and other container runtimes. Also, many official Docker images are built upon lightweight Ubuntu base images. LXC, Linux containers, is another container technology originally developed by Ubuntu. Next steps. Dive into Docker. Learn about Docker files, how to define your container images, Docker Compose for defining multi-container applications, and container orchestration platforms like Kubernetes for managing large-scale container deployments. 3. Cloud computing. Servers as a service. Cloud computing takes virtualization and containerization to a massive global scale. Instead of owning and maintaining your own physical servers, you rent computing resources, virtual machines, storage, networks from a cloud provider, like Amazon Web Services AWS, Google Cloud Platform GCP, Microsoft Azure. Models IaaS, infrastructure as a service. You rent virtual machines, often called instances, and manage them just like your own physical server, but without the underlying hardware concerns. This is what you'd typically start with. PaaS, platform as a service. You focus on your application code, and the cloud provider handles the underlying infrastructure, operating system, and often the database. SaaS, software as a service. You simply use the software over the internet, e.g., Gmail, Salesforce. Benefits, scalability, easily scale resources up or down as needed, often automatically. Cost effectiveness, pay-as-you-go pricing, avoiding large upfront hardware investments. Global reach, deploy applications in regions all over the world, closer to your users. Managed services. Cloud providers offer managed databases, load balancers, security services, and more, significantly reducing your administrative burden. Ubuntu's role. Ubuntu Server is the dominant operating system in the cloud. It's the default or most popular choice for virtual machines across all major cloud providers. The skills you've gained in command line administration, software installation, and service configuration are directly transferable to managing Ubuntu instances in the cloud. Next steps, explore the services offered by a major cloud provider. Start with a free tier account and practice deploying an Ubuntu instance, securing it, and running the web server and database configurations you learned in this book. Your continuing journey as a server administrator. This book has provided you with a strong set of core competencies. To continue growing as a server administrator and adapt to the evolving landscape, consider these areas. Networking deeper. While we covered basic network configuration, delve into advanced topics like subnetting, routing, VLANs, virtual local area networks, DHCP server configuration, and DNS domain name system management. Advanced security. Explore intrusion detection systems like fail-to-ban, log analysis tools like the ELK stack, VPNs, and certificate management for HTTPS, using Certbot for Let's Encrypt. Scripting and automation. Go further with Bash scripting, learn Python for automation, and investigate configuration management tools like Ansible, Puppet, or Chef, which allow you to manage entire fleets of servers from a central point. Monitoring and alerting. Beyond Top and Journoctal, explore professional monitoring solutions like Prometheus, Grafana, or Nagios, which can proactively alert you to issues before they impact users. Troubleshooting methodologies. Develop systematic approaches to diagnose complex problems, combining your knowledge of logs, system processes, and network tools. Specific services. Deepen your knowledge of specific applications. Become an expert in Apache or Nginx tuning. Master PostgreSQL or MySQL database administration, or delve into mail servers, load balancers, or message queues. The path of a server administrator is one of continuous learning and adaptation. The fundamentals of the Linux command line, security, and resource management are evergreen skills. By applying what you've learned and embracing new technologies like virtualization, containers, and the cloud, you'll be well prepared to tackle the challenges and opportunities of modern server administration. Thank you for embarking on this journey with Ubuntu Server Savvy. May your servers run fast, your logs stay clean, and your backups always be restorable.